Welcome, everyone. We're just going to give another minute or so for people to join before we commence. Well, might as well get started, I suppose. I'm Dylan Schiemann. I'm the JavaScript and web editor for InfoQ, and I'm also known for my work on Dojo and other JavaScript projects, and I'm currently the CEO at Living Spec. Today's webinar is focused on technical debt around JavaScript applications, and the format is fairly straightforward. We're going to start with a roughly 30-minute talk by James Smith, who's the co-founder and CEO of Bugsnag. And then after that, we'll have about 20 to 25 minutes for Q&A. I'll start by asking some questions that are interesting to me, which will give everyone some time to answer questions or ask questions that James can answer through the chat. I will collect those and sort of organize them into a nice flow. There'll be a poll roughly halfway through. If you want to answer that, you're more than welcome to. And just feel free to let us know if you have any questions or feedback. And I think I said that a lot faster than expected, so we might as well get started. And so I'll hand things over to James. Welcome, James.
Thanks, Dylan. Yeah, as Dylan says, I'm James Smith. I'm the CEO and co-founder at Bugsnag, and I like to think of myself, or people describe me as a retired software engineer. I started my career in building software for Bloomberg, building trading platforms, and I've worked at startups. I've worked in embedded software, but yeah, I'm a math and computer science grad that's turned into a startup founder. And that's my passion, really, building things. I like building products, companies. And before then, I had a lot more time before running a company to build open source projects as well. And a lot of my more recent open source projects were in the mobile space, Android libraries. But back in the day, and this really dates me in terms of my technical abilities, I wrote a few popular jQuery libraries, widgets and plugins and things like that. Before Bugsnag, I was the CTO at a company called HeyZap, which was a Y Combinator company. And before then, as I said, worked in enterprise as well. So I've kind of worn a lot of hats over the years. These days, I'm working on running and building a company called Bugsnag, and we call ourselves a stability management platform. Basically, what we do is we detect when things break in your software, no matter what part of the stack is. So once you've built your software and delivered it to your customers, our SDKs and libraries will detect when there's crashes, bugs, exceptions, all that kind of stuff, and report that back to your team to figure out what the problems are, how bad the problems are, and how to fix it. And just to give you an idea of where this is used, we've got customers who are working on open source projects using us, or little mom and pop kind of dev shops, all the way up to some of the biggest companies in the world using our product to balance their application stability while building software. So today I'm going to be talking a little bit about paying down technical debt on JavaScript applications. And before I talk about a couple of techniques, I really want to set the scene a little bit. And this will not be a surprise to anyone watching if you're familiar with JavaScript. JavaScript is one quirky language, and I'm sure you've seen a few of these examples in the past. But if you are new to JavaScript, or even if you're a seasoned veteran in JavaScript, it's very easy to get caught up with the quirkiness of the language. And I think this example at the top right here is one of my favorites. And Dylan was saying the same. String concatenation quirkiness, and oh whoops, I put an extra plus in there and I've ended up with banana, or array concatenations turning into strings. And if you are, for example, coming from Python, looking at that top left example would give you a very different result to the example that you output you get in JavaScript land. So yeah, it's very easy to get into a pickle in JavaScript land. And that bottom left screenshot there is what this would look like in some of these issues would look like inside of Bugsnag or your error monitoring platform. So this quirky, you're going to have bugs. This is not a surprise to anyone who writes software, real software. And so there can be a lot of bugs and a lot of, therefore, technical debt to address in JavaScript applications. And one of the biggest challenges, I think, in software teams, if you're building software professionally, is actually, this is also true in open source. I remember when I was trying to figure out, should I go through the thousands of GitHub issues in my poorly maintained open source project that I left for a while, or do I come and build a new feature? But yeah, in industry and in business, you want to figure out, should we fix bugs or build new features? And it's quite difficult to figure that out. And one of the reasons that it's difficult to figure that out is because every company is at a different stage, every product is at a different stage, but also there's a lot of pressures from different parts of the business. I'll talk more about that in a second. Before we talk more about that, kind of setting the scene some more, if you are writing software, you are generating bugs. That is a truth for every piece of software. And yes, there's a trend of some programming languages these days that are trying to reduce the prevalence of errors by doing things like not even allowing you to initialize variables to null or nil. But even in those languages, you're going to have bugs. So if you've got software, you've got bugs, and so you're not alone. But the process of racking up bugs for the sake of fast-paced development is known as technical debt. So probably if you're making those trade-offs that I said earlier between features and bugs, and you're writing software, therefore generating bugs, you therefore have technical debt. I'll do this really quickly, but I have to include this. This is the Webster's Defines version. Technical debt describes the consequences of software development actions that intentionally or unintentionally prioritize client value or project constraints over more technical implementation and design considerations. Now, I hate this definition. I think it's too crusty. I don't think it makes sense for a lot of the emotional side of technical debt, which I'll talk about in a second. But really, I think that the impact on a business of technical debt is it slows down the creation or maintenance of new product functionality. And if you talk about it in that way, that's a really good way to align with the rest of the business. So technical debt, I think everyone has a rough idea of what that means, and they have their own definitions of what that means. But where does it come from? Well, I break it down in three ways. I think there's deliberate technical debt, outdated design technical debt, and bit rot technical debt. So deliberate technical debt is the one I think most people are familiar with. That is, we're getting pressure from the business team or the product team to get this to market now because our competitor is also launching a feature that looks very similar. And so we're going to cut corners. And this fast coding, this for speed to market technical debt is very, very prevalent in early stage businesses where maybe you don't even know if people will pay you money for your product yet. And this is also quite prevalent in experimental features and launches. Unfortunately, it's also quite prevalent in mature companies where it shouldn't be so prevalent. But sometimes you have to make a trade-off, and this is what results of that. The next one is more of an evolving design problem. So I remember in a previous company, it was a Ruby on Rails application for the backend, and we had a model file called user.rb. And user.rb was there since day one of the business, even though we'd pivoted the company 3 or 4 times. And we'd gone from being a flash gaming arcade to a mobile social network. So quite different pieces of software that we were providing. But we always had some form of users or some form of authentication. And so the role of the user had changed quite rapidly, and no one had gone to kind of redesign that set of design decisions that we'd taken day one of the business. That example also plays really well into this last type of technical debt, which is bit rot technical debt. And this is where you add stuff to your code incrementally. And then this user.rb example I'm giving in Ruby land, again, we always had authentication, but actually the role of the user changed quite a lot, and nobody bothered to delete the old functions or parts of this model that didn't make sense anymore. And bit rot technical debt is really insidious because you think, oh, well, we're not using that code, so that code's not going to be executing. Sure, maybe it's not going to be executing if you really understand your code paths inside and out and code coverage inside and out. But one of the problems that causes is every time someone goes into that file, they're going to have to try to figure out if code is executing here. I remember in this particular file, we had a huge ASCII art dragon at the top of the file with a warning that said, "Here be dragons." And so a benevolent software engineer had added that warning, but no one had taken time to go and clean up that file. So I'm sure everyone's seen all three of those. So that's the bug side. There's a second part to technical debt, and that is the emotional drag. And so bugs, we're going to talk about a lot today, and we're going to measure how you can measure those side. But the emotional drag is equally important. The emotional drag, as I think that most of you would have experienced, bugs are fine. You're going to have bugs. That's a result of innovation. It's a result of software development. And you don't always want to fix every bug because maybe it's not that important. Maybe it's some weird Chrome extension that you don't care about that this bug is caused by. But the emotional drag is not okay. So this is something that we see a lot, especially in more mature companies, where the code base is old and management don't necessarily have empathy for the problems that the engineering team are dealing with. But if you have a disgusting code base, software engineers do not want to work in that code base, and it leads to disengagement in the software engineering team. It leads to churn, people leaving the company, and it also leads to kind of the concept of broken windows theory. If you've ever heard that theory about, I think it's been discredited these days, but the theory around if there's a broken window in a building, you're more likely to get graffiti on the building and all that kind of stuff. Well, the same is true in software code bases. If no one cares about the code base, then why should you? And then the idea of software being a craft really rapidly deteriorates. You don't get to work on building a craft. You kind of want to get in and get out of that code base as quick as possible. So how do you manage this technical debt? Well, a big part of that is building alignment between engineering and product teams. Now, when I say product teams, I mean the people defining the roadmap and what to build next and roughly how to build it at a high design level. This is sometimes called the business team in organizations. But this alignment is really, really important. If you partner on what technical debt means to the business and what the impact of that technical debt is, you can come to an understanding about why it must be addressed. Now, this is a sort of thing where in a lot of companies, people will wait until the last week of the last sprint in the launch of a product, and then when there's a lot of pressure from the product team, the engineering team come across almost sometimes as moaning about things, you know, like, oh god, this is awful, we're not going to launch this on time because we've got all these problems. And so sometimes that approach falls on deaf ears. What I think a really good approach is here is to find a common language for technical debt that the product and the engineering teams can agree upon early on in the software development lifecycle. And then that's something you can look at and measure throughout the software delivery and software development lifecycle. And it won't be something at the end where you're like suddenly saying, "Uh-oh, product, this is a problem." Everyone aligns and everyone agrees on it. So before we get into some actual techniques here of what those measurements are, I'd like to get an opinion from the attendees here. How are you measuring technical debt today? So we're going to launch a poll, and I'd love to see how everyone is measuring technical debt today. There's a couple of options, and we'll be touching on a few of these in a second. Static code analysis, so things like linting or running code coverage or code smell tests pre-production, analyzing code in production. This is things like error monitoring, crash rates, error bug rates, logging, and the last one is just not doing anything. I'd be surprised if that was a high on the results, but we'll see. I've been surprised also by how many large companies and customers that we've talked to have ended up not actually having anything in place. So maybe I won't be that surprised. So curious to see what the results look like on this one. All right, we'll give that a little bit longer for the results to come in. And when they come in, I'll talk a little bit about those results and how they compare to the techniques that we've seen and I'm going to discuss later on in the presentation. Wow, okay. Well, results-wise, fairly surprising, but we have 37% of people saying that they're using some kind of static code analysis. The smallest proportion, 27%, saying we are measuring and analyzing in production, which is actually mostly what I'm going to be talking about in terms of techniques, and a huge 37% of people saying they're not measuring technical debt today. So whew, that's quite a lot. So hopefully that will be very helpful, and people will be able to see more in the way of some solutions and examples here today, and hopefully it'll be valuable. So let me load up the rest of the slides here. So we're going to go through each of these techniques. We did the poll on here. So if you're not using anything, you have to use something. Please put something in place. I don't even care if it's the most basic open source linting product. They're free. Put them in your build pipeline. It's going to save you a lot of time. But really, I'm going to cover static techniques at a very high level, very briefly. Dynamic techniques and production monitoring in a lot deeper level. And then I'm going to briefly touch on the third one, developer groans per minute. I'll start with number 3. It sounds odd, but I'll start with number 3. So I said earlier that this emotional drag of technical debt is not okay. Well, how do you measure the emotional drag? Well, actually, if you're in a management role at an engineering organization, this should be part of your professional development and one-on-one cycles. Now, listening to people going ugh at the end of a sprint is not helpful, but having structured questioning as part of your one-on-ones and professional development is actually really easy to do. 2 techniques that I really like to measure this. One of them is to do satisfaction surveys with your development team and include questions around technical debt. So that takes these groans and people moaning about things being broken into more tactical and data-driven approaches. Another approach that I like to use is either one-on-ones where you're talking to your team and asking about how they think we're doing in technical debt, or project retrospectives. And project retrospectives are fantastic because you can loop in the product team at that point in time. So it takes this from being something where it's unstructured frustration into something that has a path to resolution and includes the right stakeholders. So that's the brief covering on the groans per minute aspect, and that is really a metric. I actually use that phrasing at our company as well. So let's briefly touch on static techniques. Now, it sounds like from the poll, this is the one that most people are using. And if you're building software with JavaScript, you're probably using some kind of linting product, and if not, please go out and use one. Now, the de facto standard in JavaScript land is ESLint, and ESLint basically is detects by using static analysis, it detects code smells and standards gaps in your software. You can run this as part of your CI/CD pipeline, or you can run it manually just by running it on the command line. But best practices here are to use linting as a gate to merging pull requests. So if you've got strict rules on linting and you cannot merge your software until the lint rules are checked off and passing, that means that you're not going to get broken code according to your linter landing in master in your source control system. One of the things that I've seen where people fail on linting is where you use very lax rules. It's very, very, very tempting to put those comments throughout your code base that say lint ignore, and hey, let's just ignore this one right here because that's okay. Now, I understand that you might want to put that in for legacy code that you don't want to clean up or you don't have time to clean up. But more and more I see customers and developers putting ignore rules in on one-offs. Now, I don't think this is right. I think that if you're going to have linting in place, you should again build alignment. You should talk to your team and say, look, this is our coding standard. We are sticking to this coding standard. And if we want to change that, let's have a discussion. Like there's contentious ones like line length, right? Your length of your lines is very unlikely to cause issues and bugs and crashes in your software. And there's a lot of religious debates about how long your line should be, especially in JavaScript these days. But that should be a discussion you have as your team. You shouldn't just say, oh no, I want it as 80 characters, I want it as 100 characters. On a case-by-case basis, decide and enforce, and then set it up in the linting rules. Another static technique, which you might be surprised to hear, is using typed JavaScript, using TypeScript. And so we used TypeScript at Bugsnag, but we didn't always use TypeScript. And so we have our React application that powers our dashboard was originally just a well-linted JavaScript application, but we are slowly moving across to TypeScript. And actually, we've got pretty good coverage now in terms of TypeScript. But this will increase confidence in your code because you have static type definitions. So some of the, I literally was just reading an issue today in our code base that I saw in Slack where someone said, hey, this bug could have been addressed if we had converted this part of the code to TypeScript. So yeah, it's convenient to have all of those quirky things of JavaScript that we talked about on the first slide. But you know what? If you're writing grown-up software, TypeScript is a nice layer on top of vanilla JavaScript that I'd highly recommend to use. One area that I didn't talk about here is code smell analysis. So there is something called cyclomatic complexity and a bunch of other code smells. That there are products out there, both open source and commercial, that will run through your code base statically and give you a score. Now, there's a product called Code Climate, their original product, which is still available, will give you a scorecard, like a report card at school from A to F, based on very common code smells. One of them being cyclomatic complexity, and another one being things like a duplicate code. If it detects two chunks of code that are exactly the same or very, very similar that should be factored out, then it will give you a warning on that. Now, these are the sort of things that you can put in your build pipeline and give you linting warnings and your score and Code Climate ahead of time. And that's all static. That's before your code gets to your customers. So what about these dynamic techniques? What I mean by dynamic techniques, is that's quite a broad term, is ways of measuring technical debt that are when your code is in the hands of your customers, in production or beta, or basically environments where your customers are using it. Now, I'm going to talk today about stability scores because I think that when I said earlier about aligning between product and engineering, stability scores are a great way to do that. And stability scores are basically just a single number on your software to say, is our software healthy, or are we generating too many bugs in the hands of our customers? But before we talk more about stability scores, I want to talk about what a bug in JavaScript is. So actually, JavaScript is not as simple as something like a Ruby or Python application where you just have one thing, which is an exception. In JavaScript, there's a lot of ways that your software can break. There's unhandled exceptions and errors and handled exceptions. Now, the first type is ones that are not handled by you. They're not expected as a developer. Handled exceptions are when you have a try-catch block and you've caught something in your try-catch block. Now, in Bugsnag land, handled exceptions don't count towards your stability score, but they can be incredibly useful in debugging. So I've seen plenty of times code snippets where it goes try some ludicrous thing, catch, and then a comment in the catch block and nothing else that just says should never get here. And I guarantee you, every time as a developer you write should never get here in your catch block, you will get there. And so with Bugsnag, you can add in a line that says bugsnag.notify and then pass in the error in the catch block. So yeah, it should never get here, but if it ever does, you'll now know about it. Now, unhandled exceptions and errors in JavaScript come in a bunch of different flavors. There are errors that bubble up to the window.onError handler, and these errors will cause the rest of the script tag to stop executing. So your code in that script tag will stop executing. One of the quirks of JavaScript is each script tag has its own, I guess runtime is the wrong way of describing it, but if you have an error in one script tag, an exception get thrown that's unhandled, all the rest of the JavaScript that was going to run next will stop running. But guess what? The next script tag will pick up and say, right, let's go. Let's try and run this code. And if that next script tag relied on something that failed to initialize in the previous script tag, you're in big trouble. So this is the one that just stops the entire page. Basically, you're kind of boned at this point because everything that you thought would happen has now stopped happening. That's the worst kind. The next one is errors in event handlers and in callbacks. Now, if you're writing any kind of real world web application, probably a lot of your code is not just executing on boot. most of your code is executing in reaction and response to your customers interacting with your product. And so bugs that happen in event handlers are super interesting, because an exception in event handler will stop that event handler from completing, but the rest of the page will continue. And so an unhandled exception in an event handler could cause something like a button to fail to click. Or my favorite, which I see all the time around the web, is form submission failures. So I've clicked a form and nothing happens. I've clicked submit and nothing happens. And that's usually because in the event handler for the submission of that form, a bug has occurred. And the last one, which if I was talking about this 5 years ago, no one would have known about, but now is pretty common, especially in modern web frameworks, is unhandled promise rejections. So promise rejections are not exceptions. They are a different beast, and you have to figure those out as well, because if you're expecting, it's kind of like the event handler scenario, if you're expecting code to execute and it didn't, you need to know if it failed. And when things do fail, you can factor that into a stability score. And the math is pretty simple. The way Bugsnag calculates it is we say, what percentage of user sessions ended in a success, i.e. didn't crash? And so the math is, 1 minus number of sessions that had an unhandled exception divided by total number of sessions. And that gives you a nice pretty number like 99.992. And in this case, we would call that 4 nines of stability. And having that number aligns with a lot of metrics I think that teams are used to using. A lot of people will say 5 nines of uptime and availability, and in this case, you can say the same thing inside of Bugsnag. You can say my stability is 4 nines. If you combine those targets, those stability scores with 2 things, SLAs and SLOs, then you help align your team. So SLA is a service level agreement. I think most people are familiar with this, and that is everything's on fire. Once we hit this number, we need to stop development and actually come and fix these things. But something that most teams don't use, and I actually think is really important, is an SLO, a service level objective. And these are terms that are very familiar to people who've ever read Google's Site Reliability Engineering book. But a service level objective is an aspirational goal for your team. And actually, we found it's a lot easier to set 2 numbers, an SLA and an SLO, than it is to set 1, because you can say we're in the sweet spot right now. Between these 2 lines is the sweet spot for software development. Ideally, you want to be riding that SLO line, but it's okay if you're below that SLO line, but it's not okay if you're below that SLA line. So this is the hard part. Figuring out how to prioritize bug fixes is important. Once you know your stability score, then you have to kind of figure out which bugs in the list matter the most. And in JavaScript land, that is a bit of the Wild West. You've got code that's executing in old JavaScript that someone's left in their browser and hasn't refreshed yet for a month. You've got Chrome extensions and Firefox extensions that are polluting the DOM and messing with your JavaScript. And in reality, you need a product like that will help you figure out which bugs actually matter. So, if you've got a Chrome extension that's messing around with your DOM and removing something from the DOM, maybe you had a bit of JavaScript that hooked onto that DOM element. And guess what? That DOM element's now gone, and therefore a Chrome extension will now cause a crash or an unhandled exception to happen on your page. But does that matter? If this is a super weird Chrome extension that you don't care about, then maybe you don't care about that bug. But if this is 1Password or Honey or one of these super pervasive Chrome extensions, you probably should care about it. If 90% of your customers are using Honey because you're an e-commerce site, then maybe you do need to fix that bug. So really, the point of this whole talk is measure, align, and stabilize. If you can move away from just reading customer support tickets and build a focus on developing metrics to align product and engineering on, you can actually start reducing that drag of technical debt. And in the end, it's okay. You've got bugs because you're building software. Everybody has bugs. Technical debt will happen. You just need to figure out how to manage it. And if you're using static and dynamic measurement techniques for technical debt, you can actually start to reduce that emotional drag and get into a happy place when it comes to technical debt. Well, that's it. Thank you so much for attending. Thank you so much for listening. And I'll hand back over to Dylan for our Q&A section.
Thanks, James. That was really lovely. Awesome information and far too many memories of bad experiences as well. So it's good to hear. So I guess while we're, if you have questions, feel free to ask them in the chat and I'll work them into my list of questions. But I guess, I would love to start with hearing about how you help some of your customers decide like what's a good target stability or critical stability, and how do you pick a good range for that?
Yeah, that's an interesting challenge. Actually, should I keep sharing the screen now, or what do you think?
I think maybe leave it open for a minute and then hide it,
Perfect.
and then maybe bring it back towards the end so people have the info for you. Yeah.
Sounds good. Perfect. Yeah, so figuring out a stability score, I think, is the best way to do it is to turn on metrics, leave it for a couple of weeks, and then look at your number and then set your SLO, your objective number, to be higher than where you're at right now. So that's the simple answer. But in reality, a lot of times people want to know what their aspirational number should be. And there's some good examples here. So it really depends on the stage and maturity of your business. If you are a young company that doesn't have that many customers and you're really optimizing on innovation, you probably are okay with having more bugs because you're trying to launch features faster. If you are a mature company, then there's a lot of competitors and people are relying on you for particular things, then you probably want to have a stricter stability target, SLO. It also depends on your industry. Like when I talk about stability scores and it's okay for bugs to get into production, I'm not talking about tech companies that are building medical pumps or banking transactional closing systems. I'm talking about consumer or B2B applications here. I'm not talking about safety and the space shuttle. This is not what we're talking about. But if you are in fintech, we have a lot of fintech customers at Bugsnag, you probably have a lot higher standards than if you are a music streaming application, for example. So it really depends on the stage of your business, but the best way to do it is to measure where you're at right now and then decide how aggressive you want to be about improving that after you have some data for a couple of weeks.
That makes sense. I guess a follow-up question to that would sort of be, you said not all bugs are worth fixing, right? So kind of, I mean, maybe that's a corollary of what you just described, which is like your banking enterprise needs to like fix everything, but maybe a new startup doesn't worry about a lot of things. But do you have other perspectives on like how to know when to fix versus when to accept that that's an okay bug?
Yeah, the prioritization aspect. Is, I think it's quite interesting because there are companies that have thousands of software engineers that can go in and triage and fix a lot of bugs, and they're actually, most companies don't. They'll have very few software engineers servicing a lot of customers. We particularly see this in consumer applications. If you're using like a music streaming application or like a Netflix kind of application or a e-commerce application, the team that's building the application is probably a lot smaller than you would imagine. And so in that case, you really have to prioritize the time that your team's spending. And so a couple of the ways of doing that depends on your environment. But let's say you're Amazon and you're trying to figure out which bugs to fix first. Well, you probably want to fix the bugs that are impacting revenue the most, if you're going to boil it down most simply. And so if you are using a stability management error monitoring tool like Bugsnag or something similar, make sure you're attaching metadata to crash reports. So you can say, was this during an e-commerce transaction? How much was the value of this e-commerce transaction? Is this a customer that spent a lot of money with us before? And so therefore you can say, right, this is a bug affecting everyone spending money with us. Let's work on that first. The other examples there might be during onboarding. If you're trying to attract and sign up a new customer, if they're seeing a crash when they're clicking the subscribe to product button, that probably should set off some alarms. That's probably the most important bug in your platform. But maybe if there's a bug that's happening in another part of the code base in a settings page where someone's updating their profile picture, that's not going to be one that you jump to fixing and page an engineer overnight about.
Yeah, that makes sense. We have a few questions from the audience, so let me break out some of those. So Leslie asks, what are some examples of dynamic techniques that you might use as a developer?
So apart from the stability score component, there's a bunch of other things that you can use as well. Uh-oh.
You've shared your screen.
There we go. Clicking a bunch of buttons
There you
there. Fantastic.
go.
Apart from stability score, there's a bunch of other things you probably want to keep an eye on. Site reliability engineering mostly focuses on backend, but actually there's a lot of techniques we can take from that to discuss on client side and JavaScript monitoring. So site reliability engineering talks about 3 pillars of reliability. It talks about availability, stability, and performance. Availability is, are my servers even running? And in a client-side application, obviously you're going to be talking to some backend APIs or services to pull data in on the client side. So you probably need that. A lot of client-side applications these days may be just purely API based. And so maybe that's not your team's ownership area. Stability, therefore, becomes that base of the pyramid. That's the most important thing for client-side applications. And stability is what we've been talking about today in stability score. Is my application actually working? The top of the pyramid is performance, and that is, am I seeing any performance issues? Now, it used to be a lot easier to have these on JavaScript applications, but if you have a freeze, if you have your application freezing up, that's a problem because that's a failed experience for your customer. But that's a whole different story for us. We've actually got some code snippets in Bugsnag land that hook into browser timing metrics that will generate a Bugsnag exception based on failed timing metrics. So rather than aggregates and averages you see in a lot of these APM tools where they're like, on average, your TP99 was this percentage. Like, they're fine, they're great, have them. But they don't tell you if individual customers have seen a poor experience or why. And so that's, I think, one of the most important things to do. Some of the other dynamic techniques you can use, there's the really old school techniques of QA, getting this product in the hand of your customers. But I think that's really slowly being replaced by phased rollouts. So one of the key use cases of Bugsnag is, let's have Bugsnag running in the hands of our customers for 5% of our customer base. So you can use a dark launch tool like Split or Launch Darkly or Rollout. You could probably roll your own, but the idea is you're getting new features in hands of your customers, but a subset of your customers, and then understanding if it's working or not. So I hate this phrase. A lot of people say test in production. I think that's very disrespectful to customers, but the idea is you're trying to ensure that what you're giving your customers is of high quality. And so I think that bugs are going to get through. So the more careful you can be about your rollout, the better you can experience you can deliver. So they're the big dynamic techniques for me.
Yeah. One of our users is asking about tools that are open source to help you identify code issues. You, of course, identified like ESLint and its variations and TypeScript as a way to help identify issues in JavaScript land. Are there other tools that you actively recommend that are available for developers?
So there is, I forget the name of this right now, but if you look up cyclomatic complexity or code smell tools, there are products out there that help you figure this out. Now, the most basic thing you can do is look at code coverage and basically make sure that when you're writing tests, am I actually testing every part of my code base? But some of the other static techniques that I was discussing aren't really about code coverage. One of the you can have 100% code coverage, but be copy pasting functions with the same bug all over the place, or have 80 nested functions that are really hard to follow. And so I think you need to just factor a lot of these things in. When it comes to cyclomatic, I forget the name of, I wish I had it off the top of my head, but if you look for like open source code smell tools or open source cyclomatic complexity, there's a ton out there based on published papers. And these are things you can put into your build pipeline. I think on the linting side, I kind of glossed over this a little bit, but if you're using ESLint, which you should be using, one of the hard things that you have to figure out is, what are my linting rules going to be? And I kind of take the approach of a very pragmatic approach, well, when I used to write software, of not reinventing the wheel, finding a set of rules that I respect and are used in production at scale that people smarter than me have used, and using that. And I think, well, I don't know if we still use this, but we used to use the Airbnb ESLint rules, which are very popular, and they're very sensible. They strike a balance between being quite strict in some areas, but also being quite pragmatic. And if you do that, then you know that Airbnb's team of 1,000+ engineers who are using this on a daily basis have sniff tested this for you. Whereas the defaults aren't always necessarily the right thing. So have a look at what applies to you. If you're a startup, go and look at big startups rules and see if they apply to you.
Yeah, and if you're using TypeScript, there is an ESLint variant of TypeScript as well that helps you get started. And if you're doing code coverage, most JavaScript testing tools just include a library called Istanbul, which helps you analyze code coverage analysis as well. Another question from the audience was, are there any sort of open source tools out there as alternatives to Sneak to help you identify security vulnerabilities? I know that GitHub actually provide, if you have an open source project, GitHub kind of just tells you, hey, you've got security issues of known vulnerabilities, but is there anything else you've used or seen in action?
I'm not a big expert in that space. We use in compared to Sneak, I'm not sure, but we use a bunch of open source vulnerability scanners on the back end, but I'm not sure if anything's equivalent to Sneak. I do know that if you're using a Bugsnag or an equivalent error monitoring solution, quite often well-written web frameworks will throw exceptions when something looks off, especially when parsing data. And we see a lot in Bugsnag where errors will show up as a result of someone prodding security holes, and especially on the back end. And JavaScript, not so much. In the back end, though, you'll see PHP errors thrown all the time, that where people are trying to look in particular file paths down the path, and anyone who's written a PHP application will know exactly what I'm talking about. But
all
yeah,
the old WordPress exploits as well. Like if you have WordPress, every WordPress exploit is tried manually in brute force. Yeah,
exactly. That still happens all day, every day. So yeah, I'm not a big expert in open source security, but I do know that if you are using something to measure exceptions, a lot of the time people prodding for holes will generate an exception.
Yeah, and I would add, I think if you have an open source project and you maintain it on GitHub, or even if it's a closed source project, GitHub's pretty aggressive at, hey, this dependency has a vulnerability. So at least it helps you find vulnerabilities up the tree, almost to a fault, because it feels like almost every day you've got to update something, but that's how it is, right? I guess, I always like to sort of dig in to like see how you got to this path. So what was that moment in time where you're like, hey, I need something like Bugsnag, and what led you to this path of like creating this product and company and focusing on this?
So when I started running the tech team at HeyZap, my previous company, 2009, there really wasn't much around that helped with kind of proactive error monitoring. Pretty much everything out there was log file based. You'd have data dump into a log file, and you'd use something like even Logstash Kibana wasn't a thing back then, so you'd use something like log concatenation manually, or your own homegrown system, or something like Splunk to dig into this data. But it was just a black hole of information. And then really, when I started doing more client-side development, that's when I started to think, why the heck isn't there an equivalent here? Because client side, you can't use log files. The logs are happening on the client devices. And so at the time, there was a couple of, I remember in Rubyland back in 2009, there was a gem called the exception notifier gem. And this gem took any web exception and emailed you. And the way that rate limiting works from that gem is literally you'd hit your Gmail rate limit, and Gmail would start rate limiting emails coming in. And so that was really like the trailblazer of this technique of living inside of the application and monitoring for problems. And so I got to the point at one point where I was like, I need like the exception notifier gem, but for Android applications and for JavaScript applications. But as you can imagine, the scale of the problem is much higher. If you have every exception from every client device, especially when we had an application that had millions of daily active users, Gmail's not going to like that. So we had to figure out a way to do fingerprinting, grouping, and all that kind of stuff. And again, there was a couple of like proto things out in the wild back then. But I had to cobble stuff together for myself. So after a couple of years at HeyZap and cobbling together our own homegrown things, we got to the point where my co-founder and I were both like, every company needs this. We need it in enterprise, we need it in startups. And so if we need it and we think every other company needs it, then hey, maybe we can provide this to everyone and make some money in the process. So it was really scratching our own itch. And the first version of Bugsnag really was quite simple compared to what we have now. It was very simple. It really effectively said, have an SDK, a library in your application, detect unhandled exceptions, and then group them using a relatively rudimentary grouping algorithm. So you could say this one bug happened 1 million times rather than here's a million log statements in your log file. So yeah, scratching that itch. Nothing, client side was, no one even thought about client-side exceptions back in the day. It was all about the back end, and it was just broken web experiences were just an afterthought. And so yeah, that was the origin
Yeah, in the
story.
early days of Dojo, we wrote something that would capture all your client-side exceptions and send them somewhere, but we had nowhere to send them to. So it was kind of like, and that was before Node. So it wasn't like we had a JavaScript server that we could just install. So it just kind of sent them to a file somewhere, and then we never did anything with that. But it was
Oh,
definitely
I
a
bet
pain
if you
point that
built
I think
your
we
own,
all felt.
everyone's had this,
Yeah.
and I bet if you rolled your own, you'd have seen all the quirks about this. So JavaScript is one of the only programming languages that does not have structured exceptions. So if you look at a Java or Python or Ruby, an exception is an object, and it has like a .name, .description, .stack trace, which is an array, and it's very easy for computers to deal with that kind of data. JavaScript is a string. You get a string, and you have to parse that string, and the string has new lines in it, and it has the exception in the new lines. Now you'd think, okay, great, it's a standard format, we'll parse it. But it is not a standard format. Every single browser has their own definition and format of that. Tabs and spaces are different. That even odd things like the line number in Safari is 0 indexed, whereas in every other browser is 1 indexed. And so it's an absolute nightmare. I know everyone who's built their own homegrown solution has been very eager to retire it.
Yeah, no, I get it. Yeah, there's this is a good segue to one of the questions from Etienne, which was one of the challenges is really about how to find out which bugs are caused by browser extensions. And I know that's still really difficult to do, but do you have a way in Bugsnag or other methods that you know of to sort of differentiate between this bug's caused by my code versus someone installed a malicious or benign extension that is breaking my application?
Yeah, we actually have a few. We have a kind of a block list that's global for a lot of really poorly behaving browser extensions. So there's some that are just like there's nothing you can do about it, and this is a badly behaved thing. So we actually have a global block list for those type of extensions. But in reality, what Bugsnag provides and any reputable error monitoring and stability management solution provides is the stack trace. And the stack trace is really, really helpful here because the topmost line of the stack trace typically shows you the last piece of code that was executing when a crash happened. And so somewhere in that stack trace, you're almost certain to see the extension. And in Chrome, I think it's like extension : / is the path of where it lives. And so if you see that pretty straight away, you can see it's a Chrome extension bug. Sometimes when there is no extension in the stack trace, it's an asynchronous problem. But almost always these are DOM manipulation issues. And so setting up your event handlers in a sensible way where they won't just completely fail if the DOM is manipulated outside of your control is always a good defensive practice to use here. But normally you can see something in the stack trace that says this is a Chrome extension. And if it's something very pervasive, which we think is a bad behaved Chrome extension, we'll add it to a global block list. And when I say Chrome extension, interchange that for any browser extension in general. Most of the big browser extensions that are really pervasive are good citizens, and they know that people will uninstall their, it's like an arms race almost. People will uninstall their extension if they're screwing with websites too much. It also really depends on industry. One good example here is if you are actually, here's a great example from today. Let's say you're trying to pre-order an Xbox, right? You're going onto the Best Buy website and you're trying to pre-order that Xbox, and everyone's sitting there and ready to go to click the button. There are extensions out there that will help you refresh the page or jump into a line or a queue, like to get your Xbox pre-order or to get your Coachella ticket or whatever it is. Now, The ticketing websites do not want you to use those Chrome extensions. And so, like earlier, the question about which bugs should I fix and not fix, probably you don't want to fix those kind of bugs. If bugs are introduced by naughty Chrome extensions, then you probably don't want to fix those kind of bugs, but they're the ones that are really sneaky.
Nice. Yeah, that makes sense. What's the craziest, like back in your days as a developer, what was like the craziest JavaScript or web development bug you ran into, and how did you, like, what was that pain like for you?
Oh, we had an awful one back in the day when it was very common to futz around with cookies in JavaScript, which you just really can't do much anymore, just because of
Thankfully,
all of the,
yeah.
thankfully.
Yeah.
But back in the day, a lot of cookie, but you used to do it for valid building an actual web app reasons. You used to futz around with cookies, and we had this awful bug, and it was so awful because it didn't throw an exception or didn't throw an error that we noticed only because of another stat. We were looking, this was at Hayes app, we were looking at our login rates. So we had a stat in our analytics with how many times someone had authenticated. And suddenly the login rate went up really high and the engagement rate in the application dropped. And we were like, uh-oh, this is a red flag. But this isn't a stat we looked at all the time. It took us 48 hours to really look at this stat. And it turned out that there was a regex bug in the cookie manipulation logic that logged everyone out of the application, every single person. And we hadn't seen it for some reason during testing. I think maybe because the regex hadn't affected people who had admin token or something like that, but it affected pretty much everyone else. And that was nasty because the only way we saw it was a trailing indicator. We saw true business stats getting screwed over by this bug. So that was the worst one. And yeah, and then we scrapped. It was really hard to find because obviously it was a regex, and it was a regex that was awful multi-line concatenated regex that looked fine, but this is in the days before having lovely regex validators and all that kind of stuff. But it was a hot mess. That took a few days to unpick. And also, once you've screwed the cookies, it's game over. So yeah.
Right. Yeah, that makes sense. That's cool. Yeah, I think I told you my issue before, which was crazy. Luckily, a lot of really classic JavaScript bugs like that aren't as problematic anymore. Now we just have new, different system level problems and stuff, but it's nice to not have to deal with those on a daily basis. I think the final question is sort of a nice way to close it, which is if you're a developer in an organization and you feel like you have a lot of technical debt, do you have any good strategies for helping a company understand the value of taking the time to fix that technical debt or remove it? I mean, you've identified a few of them, but any sort of parting thoughts on like how a developer can talk to the person who's like setting the budget and timeline and say, hey, like we need to fix this because it's blocking our ability to like make progress?
Yeah, I think that I can't mention the company name, but we have a customer who uses stability scores in their exec meetings, in their department head meetings. And I heard from them that they had a board meet. They were launching a premium feature, and the board was very excited about this premium feature going live. And the development team were able to go to the exec team and the board and say, we cannot launch this because we are below our critical stability metric. And so I think that obviously we've talked about that a lot today, but I think that having a metric like that and explaining why up front really helps. But if you use a metric that is related to customer experience rather than some kind of obscure code, like cyclomatic complexity, no one's going to care about that on the board. But 1-2% of my customer base is seeing a failed interaction is so visceral, it's so real that it's easy. It doesn't need translation. So I think the best thing you can possibly do, whether it's stability scores or whatever, but is pick a metric that is understandable and has a direct user impact. Now, you can go so far as to say revenue impact, and some companies do measure, here's how many dollars we lost due to crashes, and you can do something like, if 2% of our sessions are crashing, finger in the air times daily revenue that we're making. But I don't think you have to really spoon feed that to product and business teams. I think they can do the math themselves if you take them halfway on the journey. And I do think that's really important. A lot of development teams, and especially junior developers and ICs, will quite often say, oh, we've got technical debt, doesn't it suck that we can't do anything about it? But you know what, actually, if you do a little bit of work to translate that frustration into something that is visible to the business, and it's really not that hard a lot of the time, then everyone will get on your side very quickly. So it's about just taking that one little step from frustration to something visible and business impacting. So I think that's the approach to take.
That makes sense. Just one quick question. Someone asked where they can find the slides if they want to after the fact. Are you going to make those available, or should they just watch the video? Or either way, like they can email you or message you, I guess. But I think someone might want to watch the slides.
Yeah, I think that watching the video makes more sense because there's a lot more context, obviously, on the voiceover. But I think the slides will be available for any registered attendees afterwards, I think I heard.
Okay.
Maybe they're going to be emailed out, but I think there'll be a follow-up email that will contain links for that.
Awesome. I think that's it then. Thanks so much. Do you want to share the slides so people remember how to get in contact with you, James?
Will do.
And thanks for sharing all this useful information. And I mean, I think it's just very common now to want to have a way to track, in particular, client-side bugs, but also just to know sort of all the things that could possibly be going wrong with your application and not have to solve all of those before you have anyone using it, and not having to like expect someone to share their console when they experience a bug, but to just have that information available. And then really, I think the philosophy around like knowing which technical debt to pay down, which bugs to fix is really informative, because it's really expensive to be 100% on everything. But if you're like 50%, that's like obviously not good enough. So it's kind of like trying to get an A or a B, not an A+, and a lot of this stuff is a good way to think about it. So thanks for that perspective.
Thanks, Dylan.